All right, so good evening once again, guys. And today we are going to be starting a new topic. We're looking at graph. What the hell are you doing? I suspect that some of you are probably familiar with graph already. So if you are familiar with graph, let me see your hands, please. All right, Miss Wilson, Miss Dorothy, Miss Montgomery. Are you hearing me at all? All right, you can lower your hand now, Miss Dorothy. All right, so we are going to just look at the basic properties to begin with, and then now we'll see how we actually will use a graph paper to plot points or curves or straight lines or so on. Now, when we think about the word graph, graph really means picture, right? So if we are doing a graphical representation of something, it means that we are making a picture of something. All right, now, one of the reasons why graph is important in mathematics is that there are many things in the real world that we are studying that we cannot really see them. We don't really have a picture of them. And in order to get a better sense of the nature of how these things are relating, we use a graph to draw pictures, whether it be curve or a straight line or whatever the case may be. But in general, a graph will give us a picture. Now, another purpose for graph is that it is a tool that you can use to analyze the behavior or the relationship between two variables, all right? So we can look at the graph, and from the graph, we can determine some things about the nature of what is happening between the variables that we are putting on the graph. All right, so with that said, I'm just going to jump in the general graph. We talk about the axis of reference. Now, we have what we call the Cartesian plane. Anybody know what a plane, or what do I mean when I say a plane, or the Cartesian plane? Anybody have any idea what it means? Go ahead, Ms. Wilson.
Flat surface, sir.
A flat surface. Very good. So the Cartesian plane is a flat surface on which we have our axis of reference. Can anybody give me any idea what the axis of reference are? The axes of reference. And it is important to know that singular we call it an axis, and plural we call it axes, meaning here we have two axes. All right, so anybody can tell me about the axis of reference? What are they? Ms. Wilson, Ms. Dorothy, anything about the axis of reference that you know?
Sir, would it not be the horizontal and the vertical line?
Good. So we have the horizontal and the vertical line. Now, this horizontal and vertical line that we are referring to, these lines are generally number lines. So if you know what a number line is, you know you have a number line with a origin, a position from which you start counting. And if you count to the right, you're counting positive if you're using counting numbers. So you're moving from 0 on the line, you're going to the right, you will be going in the positive direction. And going in the, if you're going from 0, lower than 0 going to the left, you'll be going in the negative direction. So just imagine that we have two number lines that we are using to denote our axis of reference. So the axis of reference, the horizontal and vertical line that you would have mentioned, these are two number lines. All right, so let's say that that's one of the number lines. So that would be the horizontal number line, and the other one would be the vertical number line. So these number lines are right angle to each other, and they intersect at the point of origin. All right. Now, so the one that goes across, we refer to it as the horizontal axis. And the one that goes from top to bottom, we refer to it as the vertical axis. Now, oftentimes we relate variables x on the horizontal axis and the variables y on the vertical axis. All right. So generally the horizontal axis, which is the one that goes across, is also referred to as the x-axis. So in this case, this one that goes across is what we would refer to as the horizontal axis. And because we always use the variable x on it, sometimes it is referred to as the x-axis. All right. So that's the horizontal axis, the one that comes from top to bottom is the vertical axis, sometimes referred to as the y-axis because we often put the variable y on it. All right, now before we start to do anything with our graph, I want us to try and understand what the x and y represent. When we say variables, what comes to your mind? Anybody? Anybody knows what variables are? Miss Dorothy, you have any idea what variables are? Miss Montgomery, any idea? Miss Wilson, any idea?
Or would it not be the letters that you use to represent a point or so?
Well, the letters themselves represent variables.
Mm-hmm.
But the letters themselves are not the variables, so to speak. They are just representing variables. So variables are things that you will find in the real world. And anything that you can think of that have various forms of it would be a variable. Like for instance, if you're thinking about days of the week, weeks, or the days of the week, those can be considered as variables, right? Because you're moving from one day to the next. So you have different or a variety of days of the week, right? We also have variables in terms of, say, temperature. We can think of how the temperature varies throughout a certain period. It can be even throughout a week or 2 weeks or so on. So the temperature in that respect would be a variable. Now, there are many variables in the world that we are living in, right? And so there are times when we want to show some kind of relationship with the variables on a graph. So we want to look at how one variable relates to another. All right. Now, because in math, we are not pointing out any specific variable that we are putting on the graph. We just call one variable X and we call one variable Y. But remember now, in algebra, X and Y can be anything that you choose X and Y to be. All right. Any question about what I've just explained to you guys? Is that clear to you? Ms. Waysome, do you get an understanding of what I've just explained?
Yes, sir.
Ms. Dorothy, any questions?
No, sir.
Ms. Montgomery, any question at all? I realize that Ms. Montgomery tends to be silent most of the time. I don't know why. All right, so with that said, we want to look at now. So we start our measurement from the point of intersection. Now, if we are to look at where these two lines intersect or where they cross, it would be right at that point in the middle there, right? So that is the point of intersection. So any point where the lines cross, where the two axes cross, that is what we call the origin. Now, why do we refer to the intersection as the origin? Now, remember I was saying earlier that these are two number lines, and if you put them to cross where you start your counting, so wherever you start 0, and remember that a number line has a, positive and negative values and 0. So if you cross the two number lines at 0, then it means that that would be the origin from where we will start our counting. So if we're going to the right, we will count from the intersection. We're going to the left, we start counting from the intersection. We're going above, we count from the intersection, and we're going below, start our counting from the intersection. Is that clear to everybody? All right, so the point O is called the origin. The line drawn horizontal to the plane is called the horizontal axis, usually referred to as the x-axis. Now, the line drawn vertically to the plane is called the vertical axis, usually referred to as the y-axis. All right. Now, above, to the right of the origin, meaning that we would be counting along the x-axis. So if you're counting along the x-axis from the origin, so the origin is where you would have the 0. And if you're counting to the right, 1, 2, 3, 4, etc., then of course, these values will be positive, right? Now, if we are counting to the left, and as we say, it's a number line. So if we're counting to the left, -1, -2, -3, -4. So these values would all be negative, right? Because on the number line, any number going to the left of 0 would be smaller than 0, right? So those are negative numbers. All right. Now, above the origin, that means we'll be on the y-axis, then our values would be positive. So we'll count on the y-axis, 1, 2, 3, 4, 5, and so on. So the numbers above the origin will be positive on the y-axis. All right, so these are pretty much straightforward things that you would have known. Have you done, once you have done graph before. Now, so the next thing now is below the origin, we would have negative values on the y-axis. So you have -1, 2, 3, 4. All right, so everybody should be pretty much clear on what we have just done. Any question about that, guys? Any question, Ms. Waysam, Ms. Darty, Ms. Montgomery?
No, sir.
All right, good.
No, sir.
All right, so clearing and moving on then. So here now we'll talk about coordinates. Now, coordinates are used to mark the points on a graph. All right, definition: coordinates that are measured along the x-axis are called x-coordinates. Now, in some books, more advanced book, the x-coordinates, which would be a measure of an x value, is sometimes called abscissa. Now, when you measure your x-axis along, your x-coordinate along the x-axis. So coordinates that are measured along the y-axis are called y-coordinates, or in some books you would call them ordinates. All right, so abscissa, ordinate, these are just other words that are used instead of x-coordinates and y-coordinates. All right, moving along. Now, a point on a graph is plot using a measure of x and y coordinates to that point. So it means that in order to find a location on the graph, you would have to measure along the x-axis, however much distance that you're measuring. So you measure along the x-axis that amount of distance to the point, and then you will also measure along the y-axis the amount of distance to the point. All right. So here we have a point P, and we want to plot this point P so that x is equal to 8 and y is equal to 10. So here's our graph, and if you notice, if we move along our axis, now this is a graph where we are only working with the positive side to the axis. So we are working with the positive x, and we are working with the positive y. So here we would have y. All right. Now, if we are counting along the x-axis, we want to find 8. So we move along the x-axis from the origin. So we are counting from that origin 0 position. So we count 1, 2, 3, 4, 5, 6, 7, 8, right? So this is our x position. Now on the y-axis, we want to move on the y-axis 10. Now on the y-axis, we are counting by 2. So we are moving 2, 4, 6, 8, 10. All right. Now, so what we do, we look now to see from the 10, if we draw a dotted line from the 10 right across, and we draw a vertical line from the 8 going up to where these two lines intersect, then that would be the position of our point P. All right, so P would be right here. And so if we are labeling that point in terms of the coordinates, we would put the coordinates in brackets where we put the X value first, which is 8, comma, followed by the Y value, which is 10. And that's how we label our points. All right. So that is an example of how we would plot a point that has an X value of 8 and a Y value as 10, a Y value of 10. All right, guys. So is that clear to everyone? Now, having plot this point, one of the things that we may want is to draw a line from the, if we have from the origin or point moving from the point of the origin, then we may want to draw a line from the origin to the point that we plot. And so here we would end up here. And so this line from the origin to that point would represent the distance a point is away from the origin. All right. Now, how can a graph help us in this case when we are plotting? Now, when we are plotting points, it is a way of locating position on the graph where that point is. It is a practice of pirates back in the days when they want to mark where they would have hid their treasure. Sometimes they would dug out some hole somewhere on the shore, and bury their treasure. But what they would generally do is to ensure that they can, whenever they come back, they can relocate that point. So sometimes they would use a coordinate system in order to find where they bury their treasure. So they may have a landmark where they would start as the origin, and maybe if they are, say, using some kind of measurement, now that measurement could be in terms of maybe how many steps you go east. So maybe if you call this east, they may want to say, all right, if I walk 8 footsteps east, and then I go 10 footsteps north, then I should be able to locate where I've buried my treasure. So coordinates is a way of finding a position, not just on a graph, but you use your coordinate system too when you're looking at the Earth geometry, right? So you can think of the Earth cut up into different grids of X and Y values. And so you could actually find location on the Earth using coordinates. A matter of fact, if you had gone to, say, any of you had gone to places like the United States or, like New York in particular, you'll realize that you have a lot of what they call streets and avenues. And in New York, what they do, they will have the streets and avenue forming more like a grid of a graph. So if you look at your vertical lines, those would be running vertical. those would be considered the streets. And if you look at your horizontal lines going across, those would be considered as the avenues. So if you want to know your place where you are in New York, you just want to know what number street you're on and which avenue, number avenue you're on. And then you can work your way back to some other point of origin, right? So you really don't need anybody to really move you from one location to the next once you know which street and which avenue you're going to be and so on. So that is also one way in which a coordinate system is set up. All right. Any question, guys? So here we see that this would be our point. And if we have another point from the origin, we could connect those 2 points to form a line. All right, so moving on. Now we're going to talk about scale. Now, if you had noticed on this graph, the one that we were looking at before, you would notice that we number the intervals on the x-axis, and we count from 0, 1, 2, 3, 4, 5, 6, up to 9. But on the y-axis, we number the interval and we count from 0, 2, 4, 6, 8, 10, 12. Now what it tells you is that we are using a slight different numbering on the x-axis than what we are using on the y-axis. And so we are saying that we have a different scale of measurement on the x than on the y-axis, right? So now how do we determine what our scale is in terms of a graph paper? Well, it has to do with the measurement along the intervals of the graph paper on the x-axis as well as on the y-axis. And so I'm going to explain that in a little bit more detail for you. All right. So for this graph, we see that we have, if you count in terms of the interval, you would have 1, 2, 3. Sorry, you have 1, 2 intervals. So every 2 interval on the x, we count 1. So we have from 0 and we count 2 interval, then we have 1, we count another 2 interval, and then we have 2, and so on. So what you notice, the scale on the x-axis is that every 2 interval equal or represents 1 unit. Every 2 interval on the x-axis represents 1 unit. So that would be the scale for the x-axis here. But on the y-axis, every 1 interval represents 2 units. So every time we go 1 interval on the y, we give it a value of 2. So we go 1 interval, that would be 2. Another interval, that would be 4. Another interval, that is 6, and so on. So on the y-axis, our scale would be 1 interval represents 2 units, right? And so it is clear that the x-axis has a different scale from the y-axis, which is not a problem, because there's a reason why there are times when we may want to change the scale. So it depends on the measurement that we are using. So we have to determine our scale based on the measurement that we are using and how we would like these measurements to be appeared on the graph. Any question about that? All right, so with that said, we say that the number of units represented by a unit length along the x-axis and the y-axis is called a scale, right? So as I just explained to you, So the units, so the number of units represented by the unit length. Now remember, when we're looking at this now, when we say the unit length, we're talking about the interval. How many intervals give you a unit length? So on the x-axis is 2 intervals that give you 1 unit length. On the y-axis, we have how many intervals give you a unit length. Now on the y-axis, we have 1 interval represent 2 units. So it means if we were thinking in terms of 1 unit length, it means then half of the interval would be 1 unit, right? On the y-axis. So in that case, we know that our scale here would be 1 unit length, or 1 interval length give you 2 units on the y-axis. All right, so going back to what we're saying. So for instance, 1 centimeter could represent 2 units on one or both axes. Now, we're going to now take a look at an actual graph paper, because we have to understand in terms of the various intervals, what the measurements, the actual measurements are on the graph paper, because the graph paper is measured in different units, right? And their actual measurements. So these measurements on the graph paper, they're accurate measurements on the graph paper. But what we use in terms of our scale, we have to use these actual measurements. Based on these actual measurements, we will use them to represent our unit. So as we are saying, for instance, 1 centimeter could represent 2 units on one axis. It could be represented on the x-axis, and or both axes could have the same scale. So it doesn't mean that if you have a scale on the x-axis, you have to have a different scale on the y-axis. We can have both axes having the same scale, but there are times when we may need to change the scales based on the range of values that we are dealing with. All right, so we know NB. Note briefly, the scale does not have to be the same on both axes. All right, so this is an actual graph paper representation. All right. Now, can anybody tell me what they're able to identify in terms of the boxes that you're seeing on this graph paper?
They're squares, sir.
All right, so how many size boxes you can identify?
Sir, 2. Smaller size and a bigger size.
All right, so we notice that we have these tiny boxes, right? Everybody see those tiny boxes. And we also notice that we have some medium-sized boxes. And I'm hoping that everybody actually brought have their graph paper with them, because what you should be doing now, you should be looking at your graph paper and identify these actual measurement techniques. So please, if you have your graph papers with you, just take out a sheet of the graph paper and try to identify all that I'm illustrating here on the screen, right? Now, sometimes based on how some of the graph leaf, they may print a highlight of this. So you may have a box. Highlighting, depending on how your graph paper look. So you might be able to see this bigger size box as well.